This is part 3 of section 3.3. We're going to add a new formula. This is called the change of base formula. Now, we know that we've been dealing with all kinds of logarithms and all kinds of different bases, but the problem is that our calculators can only handle common log and natural log. So whenever we need to use a calculator, we're going to have to use this formula. If you have log base b of x, you can convert it to any other base of log by simply taking the log of your argument with the new base and dividing it by the log of your base here. So if I went to log base a, I'd have the argument up top and the base on the bottom, or common log or natural log, and it does not matter. Okay? So let's compute log base 3 of 15 by changing to both common logs and natural logs, and then we can use our calculator to see that we get the same answer. So if I want to convert this to common log, log of the argument over log of your base. And if I'm using my calculator here, log of 15 divided by log of 3 gives me approximately 2.46497. Okay, and then if I do the same thing with a natural log, you will see that you get exactly the same answer. So it does not matter which one you use. It's going to depend a bit on the rest of your problem. Sometimes you're going to have an e in the problem, so using natural log will make more sense. Sometimes you'll have a 10 to a power, so using common log will make more sense. It just depends on the problem, and it does not matter which one you use, just so long as you're consistent. Okay, so let's look at this one. Find an equation of the form y equals c plus b common log of x, whose graph contains the point 3, 3, and 9, 1. And then we're going to repeat it to find an equation of the form y equals c plus b log base a of x. Okay, so if I'm just starting off with y equals c plus b log of x, I'm going to plug in 3 and 3. And I have that. I want to solve this for one of my variables, and c is easiest to solve for. I would get c is equal to 3 minus b log 3. Okay, now I'm going to do the same thing again, but instead of the c, I'm going to plug in this, and I'm going to use 9 and 1. So I'll have y equals, so 1 equals c you can put that in parentheses if it will help you see what you're doing, plus b log of 9. Okay, now I want to try to solve this for b. So the parentheses here are only to help you see what c was. It actually doesn't make any real difference. So if I subtract 3 from both sides, I have negative 2 is equal to, and I'm just going to rearrange these right now. Okay. Now I can factor a b out of this. And we know if we have two logs with the same base that are subtracted, we can divide their arguments. So this is negative 2 is equal to b times log 9 divided by 3 is just 3. Now this is just a number. It's an ugly number, but it's just a number. I can divide both sides by that, and I get my b value is negative 2 over log of 3. Okay, so now I have a full number for b, but my c value is still defined in terms of b. So I need to get a better version of c. So I'm going to take this and plug it in right here. I get c is equal to 3 minus, and I'm just going to put this in brackets so that it's easier to see what's going on here, negative 2 over log of 3 times log of 3. That should not look like a base. Sorry about that. Either way, these cancel out. You get c is equal to 5. So for the first part of this, your first answer is y is equal to 5 plus b log x. So plus b is going to be minus 2 over log of 3 times log x. Okay, or another way of writing this, I'm just going to rearrange this a little bit because this is the answer they'd be looking for in the first part. But if you rearrange this a little bit, you have that. Okay, now for the second part of this, they want it in log A form, log base A form. Well, if you look right here, this could very easily be a change of base. And I can basically start off like right here and go back to here. Okay, so this is the same thing as y equals 5 minus 2 log base 3 of x. And that's what they want for the second part.